So back to standard deviation. The standard deviation, remember, is a measure of average spread from the mean. So on average, given we know the mean of a data set, how far are all the other numbers from the mean? So standard deviation is one way to calculate that. It's the most useful, the most popular way to do so. So you can't talk about standard deviation without the mean. And that's important because you can't compare standard deviations from one group to another without also comparing the mean. So comparison for standard deviations from different samples or different groups requires we also consider the mean, because standard deviation represents spread from the mean. And the way to think about it is if you just think about, little kids, if one little kid is a little bigger than another little kid, and maybe they are only 1 inch apart, that's a big deal for them because they're not very tall. But if we have 2 adults, and those adults are 1 inch apart, that's not as noticeable because the adults are much taller. So in this case, we're talking about maybe 1 out of 36. In this case, we're talking about 1 out of 72. Right? Those are 2 totally different comparisons. Here, 1 out of 36 is a bigger deal than 1 out of 72. And if you look at those fractions, you would see that. And that kind of gets back to the idea of the comparing standard deviations from different samples, because different samples will usually have different standard deviations and different means. So you can't directly compare standard deviations. To compare them, what you have to do is take the standard deviation and divide it by the mean for that sample. When you do this division here, this is what's called the coefficient of variation. So how big is the standard deviation compared to the mean? And so that looks like 7, but it's really an X bar. So I'm looking at the STDEV, standard deviation divided by the mean. And this is the only way that you can accurately compare standard deviations from 2 different groups or 2 different samples. The coefficient of variation is usually stated as a percentage. So let's take a look at a data set that'll allow us to compare 2 groups and how their spreads compare. So a while ago in the About You data, we had taken a look at gender versus height, and we have the males versus the females. And on average, the females were around 65 inches tall and the males were around 71 inches tall. The females had a spread of 3.59 inches and the males had a spread of 2.69 inches. We took a look at that also in stat keys. I want to do that here too, and then we'll come back and look at coefficient of variation. That was one quantitative, one categorical, because I have height versus gender. I can swap my numbers in there. And the box plot I thought was the most revealing thing. So we can see there's not as much spread in the males. They tend to be taller and they have a smaller standard deviation. The females happen to be shorter with a bigger standard deviation. Now, again, clearly the females have more spread, but we can't, again, just compare the standard deviations because they have different means also. So the correct way, the more accurate way to compare them would be add another calculation to our basic statistics. Just squeeze that in here. I'm going to call it CV for coefficient of variation. So let's just write most of it out. Coefficient variation. And the way we usually calculate it, two things is first, we take the standard deviation and we divide by the mean. And then we display it as a percentage. And 1 or 2 decimal places is fine. So with respect to the mean, the percent spread of the females is about 5.5% from the mean. And the males is 3 3/4 roughly is their percent spread from the mean. And what the coefficient of variation does is it just kind of takes out the fact that they have different means and just looks at percent spread from the middle, which is a more fair comparison of the standard deviation version of spread. So coefficient of variation is needed whenever we're comparing two groups that don't have the same mean and we want to compare their spreads.